right, let's start using our derivative to figure out if our functions are increasing or decreasing. So we can test where an interval is increasing or decreasing by just looking at the derivative. Remember, if the derivative, or the slope of the line, is positive, then I know that my graph is increasing on that interval. If my derivative is negative, well then I know that my graph or my function is decreasing on that interval. And if my derivative is 0, my slope is 0, then I know that my graph is constant in that interval, right? But how am I supposed to know when it's positive and when it's negative? Well, what we first have to do is look for what we call our critical numbers. Critical numbers for a function are those numbers in the domain of the function for which the derivative equals 0 or the derivative does not exist. So critical numbers are where my derivative equals 0 or where my derivative doesn't exist. Do you remember my derivative equals 0? Let's think about that. If my function increases, decreases, increases, at this point right here, isn't the slope of my tangent line 0? We've kind of talked about that before when we graph derivatives, right? Or if you look at the point down here, my slope of my tangent line, that slope right at that moment is 0. But what happens right before and right after my derivative is 0? Well, let's say that these 2 points were, I don't know, the point 2 and 5. At x equals 2 and x equals 5, my derivative was 0. Well, if my derivative is only 0 at those two x values, then what does it have to be right before x equals 2? Well, it either has to be positive or negative, right? So I should be able to pick any x value in this interval, plug it into my derivative, and if I get out a positive number, I know that my derivative is always going to be positive in that interval, and my function's going to increase. If my derivative is negative in that interval, well then I know that my graph is going to decrease. Same idea with all the other intervals. If I know that my function only is 0 at x equals 2 and x equals 5, I should be able to plug in a number in between 2 and 5 into my derivative to figure out if it spits out a positive or a negative number. So then I can tell if my graph is increasing or decreasing. Same idea with the interval after 5. But I've got to first be able to find those critical numbers. Where does my derivative, where does my graph have a 0 slope? Where does my derivative equal 0? Now, my graph doesn't just increase and decrease at nice smooth little curves. Can I have a graph that decreases and then increases at a sharp curve? But do you remember, my derivative doesn't equal 0 there. At a sharp curve, that's a point on my graph where my derivative doesn't exist. So that's why it's important to include both of these. I need to be able to first figure out where my derivative equals 0, a nice smooth curve, or where my derivative doesn't exist, a sharp point, and then I can figure out what's happening on either side, if my derivative is positive or negative, which will tell me if my graph is increasing or decreasing. So we're going to apply 3 different rules. Anytime they take away our picture and just give us a function, and they ask us where our function is increasing or decreasing, we're going to, number 1, find our critical numbers. Remember, critical numbers are where our derivative equals 0 or where our derivative doesn't exist. So we have to find the derivative. Once we find those critical numbers, we should be able to figure out then what intervals we have to test. What we're going to do then is we're going to test values in each of the intervals in our derivative. If our derivative is positive, our original function is increasing. If our derivative is negative in that interval, our original function is decreasing. So then we can figure out where it's increasing or decreasing. Let me show you an example. Example number 2 gives us this function, f of x equals x cubed plus 3x squared minus 9x plus 4. It says to locate all the points where the tangent line is horizontal. Well, if I have a horizontal tangent line, that means that my tangent line has a slope of 0. And hopefully we know now that the slope of a tangent line is another word for derivative. So really, all it's asking me in this question is for all the points where my derivative equals 0. So the first thing we have to do is find the derivative. So pause the video, find me the derivative of this function. I ended up getting 3x squared plus 6x minus 9. And we want to figure out where our tangent line is horizontal, or where it has a slope of 0, or where my derivative equals 0. So I'm going to take my derivative and I'm going to set it equal to 0 and figure out what x values this happens at. I'm going to solve. I'm going to try to factor out a greatest common factor first. So I'm going to GCF out a 3. That left me with an x squared plus 2x minus 3. I'm going to then continue to factor, figuring out numbers that multiply to negative 3, that when I add them together I get positive 2. I ended up getting x plus 3 and x minus 1. And now I can take all three factors and set them equal to 0. When I set the first one equal to 0, 3 equals 0 just kind of goes away. It doesn't give me an extra answer. I end up getting x equals negative 3 and x equals 1. These are all the x values where my derivative equals 0, aka where my tangent line is horizontal, right? All right. Find the intervals for which the function then is increasing or decreasing. Well, if we want to figure out where our function is increasing or decreasing, we first have to figure out our critical numbers. Well, wait a second, didn't we just do that in part A? We found all the places where our derivative equaled 0 or didn't exist. In this case, there were going to be no values where it didn't exist. It was a nice polynomial function with smooth curves, and so it was always going to have a derivative value, but the derivative was 0 at x equals negative 3 and x equals 1. So if we want to use those then to figure out where the function is increasing or decreasing, what I do is make a little sign chart, kind of like a number line. I know that my critical numbers are at negative 3 and 1. I've got to figure out then, right before negative 3, what's happening in my derivative. If my derivative is positive, then I know my function is increasing. If my derivative is negative, then I know my function is decreasing. I also want to figure out what's happening in my derivative between negative 3 and 1. And then I also want to figure out what's happening in my derivative after 1. Is it positive or negative? So that's what I'm going to do. I'm going to pick a number less than negative 3. I'm going to plug it into my derivative so I can figure out if my derivative is positive or negative. So plug in negative 4 into your derivative. Remember, your derivative was the 3x squared plus 6x minus 9. If you plug in negative 4, you should end up getting a positive number out, right? That means my derivative is positive in that whole entire interval. It cannot change to negative until it hits 0, right? Think about that. I can't go up and then change to going back down unless it hits 0 for at least a split second. So my function is always going to be what in that interval? Increasing or decreasing? Increasing, right? Because my derivative is positive. If my slope of my tangent line is positive, if my derivative is positive, then my function has to be going up, has to be increasing. Now let's test the interval in between negative 3 and 1. So pick any number in between negative 3 and 1. To me, the easiest is 0. Plug that number into your derivative and see if it spits out a positive number or a negative number. I plugged in 0 and it spit out a negative number. I think negative 9, right? And since my derivative is negative in that interval, if my derivative is negative, then that means my original function is what? Decreasing, right? It has to be going down if the slope is negative. All right, test a number on the other side of 1. Test a number bigger than 1 in your derivative and see if your derivative is positive or negative. I tested 2, and I ended up getting a positive number. If my derivative is positive, I know that my function is increasing. So I know that my function is increasing, it's decreasing, and then it's increasing again. Maybe something like this. That's a rough sketch, but it maybe looks something like this. So I can tell you the intervals where it's increasing or decreasing. I know that it's increasing from negative infinity to negative 3, and then again from 1 to infinity, because the derivative is positive. And I know that it's decreasing from negative 3 to 1, because the derivative is negative. Right? And so I have created questions on your exam for chapter 13 that are almost fill in the blanks, making sure that you understand that kind of vocabulary. For example, one of the questions might be something like, when the derivative is negative, the original function is blank. Well, if the derivative is negative, I know that my original function is decreasing, right? Not negative, but decreasing. Or if my original function is increasing, then my first derivative is positive, right? And so making sure you understand that terminology to determine if a function is increasing or decreasing.